In this video, we'll talk about how to solve exponential equations. Of course, in order to solve an exponential equation, we'll have to use the inverse function for an exponential function. And as we just saw, that's the logarithmic function. So, just like with all our other types of functions, we're going to isolate the exponential part. In this first equation, we see that's already been done. We have a power isolated by itself on the left. So now it's time to take the log of both sides to apply that inverse function. Now I can choose any base I like for my log, so I'm going to take the same base as my power. But of course I can't just do that to one side or just part of a side. I have to do it to both sides in their entirety. Now if I take a look at that left-hand side there, and we think of our exponent law, I'm taking the log of a single power and the bases match. They're both 2. So that means that my left-hand side perfectly unlocks and I just get the exponent, 7x plus 1. On the right-hand side, the log base 2 of 16, what exponent do we have to raise 2 to get 16? Well, 2 to the 4 is 16. So now I have a nice linear equation, and I can just solve it. And if you check that back in the original equation, of course, we would get 7 times 3/7 is 3 as our exponent, plus 1 is 4, and 2 to the 4 is 16. So it does work. So just again, our key tactics here for solving an exponential equation are to isolate the power on one side of the equation, if you can do that. Then you take the logarithm of both sides of the equation with an appropriate base. If there's just one power, you'd use the same base as the power. And then it should break down into maybe a linear or quadratic equation. You should be able to solve it. Let's take a look at a couple more examples here. For this next one, again, we see that the power has been isolated. So I'm going to take the log of both sides. Now here's a very important note. Just like we did with our radical functions, I don't get to pick and choose what goes in. The entire thing goes in brackets, and we take the log base. I'm going to take 3 here to match the power. Of course, the other side has to go in brackets, all in one bracket. And I'll have to take the log base 3 of it as well. Now on the left-hand side, we've got the log of a single power. The bases are exactly the same, so they perfectly unlock, and we're just left with the exponent. On the right-hand side, I need to ask myself, what exponent do I have to raise 3 to get 81? Well, it turns out 3 to the 4 is 81. 3 times 3 times 3 times 3. So now again, I've got just a nice linear equation. And we can check it back in the original equation and see that it works. Let's try another example here. Okay, so here we've got a little coefficient in front of my equation. I'm going to quickly rewrite that as a fraction, so it'll be easier to work with without a calculator. Okay. And 7,000 divided, I'm going to multiply both sides by 4/5. So I'm going to get 1,400 times 4. I'm going to get 5,600 over there on the right-hand side. And on the left-hand side, I'm just going to have my power. So here I'm trying to isolate my power. I'm just multiplying both sides by 4/5 to clear out that fraction in front of my power. Okay, but now I have exactly the same question, type of question that I had before. I can take the log of both sides, so we'll throw brackets around that. And we'll take the log base 10. If I want to get fancy, I don't even have to write the 10, since a log without a base is assumed to be base 10. And again, we see the bases perfectly match, so I get 0.02t on the left-hand side. And on the right-hand side, well, it's not that great a number, so we'll just leave it as, heck, let's get fancy. Let's write it as log base 10 of 56 times 100. And we could use a log law over there. So we'd get the log base 10 of 56 plus the log base 10 of 100. Now, the log base 10 of 100, it's the exponent you raise 10 to get 100, it's 2. And now all I have to do is divide both sides by 0.02. Now 0.02 is 1 over 50. So dividing by 1 over 50 is the same as multiplying by 50 over 1, multiplying by 50. So I'll just multiply both sides by 50 here. And there we have our answer. There's our t-value there. All right? So go to WebWork and try some examples for yourself. It'll take quite a bit of practice. Remember, you have to take the log of the entire side. You can't pick and choose. And you need to apply the log with the same base to both sides as well.